All right, we've gotten to a point where we should now be able to distinguish between a mixture, an element, and a compound. And we're now at the point where we want to ask ourselves, what is a compound, and how do we know what compounds look like? And by look like, I mean like model of the compound. So that's the question that we're going to ask in section 4.2 today. So scientists start thinking about this question, like what do these compounds look like? We know that matter makes up everything, and that different types of matter look differently, but what do they look like? So the question arises, if we take different things and we combine them via chemical reaction, what does the resultant product look like? And maybe by changing the amount of reactants that we start with, can we change the look of the product at the end of the day? Well, it turns out that by discovery, we keep coming up with this same idea, this same conclusion. We're going to take something simple, water. The scientists back in the 1700s keep figuring out that water always contains 8 grams of oxygen for every 1 gram of hydrogen. And if you're wondering, well, how do they keep coming up with that? We'll see that tomorrow. We'll figure that out tomorrow in class. But they keep doing this. So in our picture on the right side of the slide here, if they have any amount of the hydrogen that I've just circled there, and they combine that with any other amount of water that I'm going to circle in yellow right here, they always come up with a sample of water on the right side, which I'm going to circle in green right here. They always come up with a sample of water that has 8 grams of oxygen for every 1 gram of hydrogen. So it doesn't matter if they'd use 1 billion kilograms of hydrogen at the beginning or 1 single gram of hydrogen at the beginning. The ratio of oxygen to hydrogen at the end is always 8 to 1. And this is curious. So this observation continues to happen, and it is an observation, so we are able to state it as a law. It's now called the law of constant composition. And the law of constant composition applies to more than just water, and it states for a given compound, there are always the same proportions by masses of elements. Okay? So for any compound, the proportions of the elements are always the same. So water is always H2O. So that's the law. Now remember, laws just describe observed behavior. They don't actually explain that observed behavior. Well, luckily along comes this guy, John Dalton. That's him in the lower left-hand corner there. And he says a couple of things in a theory that he postulates. He says, okay, first of all, elements that we know of on the periodic table, which wasn't invented when he was around, but these elements can combine to form compounds. And then he says the second point, which is very important in his theory. He says a given compound always has the same relative number of types of atoms. So he is saying the reason that the ratio of oxygen to hydrogen in mass is always the same is because the number and types of atoms in every single water molecule are always the same. And it applies to more than just water. I've got a couple examples here. Here's water in the bottom left of my little image. Okay, right there. But other things like nitrogen dioxide, check, that same thing happens. Nitrogen monoxide, nitrogen dioxide, carbon dioxide. And even things that combine a little interestingly, and we'll figure this out tomorrow, these things called diatomic molecules, they always combine the same exact way. So this is his reasoning for why we always get the same ratio of masses when we're looking at a compound. Okay, so the main idea here is that water is always H2O. It doesn't matter how much hydrogen I start with or how much oxygen I start with. The combination of those two things is always going to produce H2O. Okay? So hopefully now you're curious and you're saying to yourself, how do we know this for sure? That's a great question. And I'm going to keep you thinking about that question hopefully overnight, and we will answer it tomorrow in class.